Okay, so page 534, we're going to talk about number 11 to start with. So the first thing that they tell me is I have a regular hexagon and the radius of the inscribed circle is 12. So if you guys take a look at my picture, you can see that what's happening is they're telling you essentially that the apothem of your regular hexagon is 12. So if you look, that's the radius of the circle. Okay, if it said the radius of the hexagon, that would be different. That would be over here, this line. But they didn't. They said the radius of the circle. So I highlighted that 12 there in orange. And then I drew in my right triangle, guys. So as I drew in my right triangle, it ends up being, of course, a 30, 60, 90 because we're dealing with that regular hexagon. And then the side across from the 60 is always equal to 12. Is always equal to x root 3. So I set that equation up over here on the left, and I went through and I solved it. So I got x is equal to 4 root 3. Keep in mind, if the bottom is 4 root 3, I'm looking for the whole base of this triangle, which is 8 root 3. And because this is a hexagon, we have 6 8 root 3s for the perimeter, which ends up being 48 root 3. And then, of course, the apothem, or the height that we're multiplying it by, is 12. So for number 11, you should get 288 root 3. Let's move on to number 15. So 15, again, gave you that, it says a circle of radius 12 is circumscribed about each regular polygon. So as you can see, I put in the radius of the circle right here, which is 12. And then keep in mind that this is an equilateral triangle, which means each of the angles are 60 degrees. And if I take that 60-degree angle right here and I cut it, I end up with this 30-degree angle down here. Okay, so again, all I did was I solved my 30, 60, 90. I wrote like my basic 30, 60, 90 right here so you guys can see how I solved it. But the side across from the 90 is always equal to 2x. Therefore, the side across from the 30 is always equal to half that. And that 6 ends up being the apothem of the triangle. So that's why you see the 6 over here, okay? The base of my triangle ends up being 6 root 3, and if you take a look at that, the base of this triangle should be 12 root 3 because it's double. Okay, so I had to double it to get that answer up there, right there. And because there are 3 sides, each of them being 12 root 3, I then have a perimeter of 36 root 3. For B, over here, again, now we're dealing with a square, and so when I draw my right triangle, it ends up that it is a 45, 45, 90, and the base and the apothem end up being equal to each other. They both end up being 6 root 2. And again, you can see how I solve that, because if the radius of the circle is 12, and that's the hypotenuse of my 45, 45, 90, that's equal to x root 2. And then you can go through and solve to get 6 root 2. My last one over here, again, so this is a regular hexagon. They told me the radius is 12, so you can see I drew that in there. I put my 60-degree angle in there. I set up my equation. Because the base down here, this pink side is 6, this piece is 6, meaning this entire side has to be 12. So that means the perimeter of the shape is 72, and the apothem is this green height that I found right here, and that's where I did the 6 root 3 for the apothem. 1/2 perimeter times apothem. So that was essentially number 15. And there we go, blah, blah, blah. Let's look at number 10. So find the area of an equilateral triangle if the radius of its inscribed circle is 3. So again, fancy words, all they're telling you essentially is you have a triangle, and this apothem right here is 3. Okay, so, and they want us to find the area of the triangle, yes. Okay, so the first thing I did, again, was I put my 30, 60, 90. This is an equilateral triangle, so I split the 60-degree angle in half to 30. If the side across from 30 is 3, the side across from 90 has to be 6, and the bottom side would be 3 root 3. Okay, so keep that in mind. I put this side over here as 3 root 3 as well, meaning that the entire base has to be 6 root 3. So this is 6 root 3, and this is also 6 root 3. So each of those are 6 root 3. The next thing I did is we're trying to find the area of this, and it's up to you how you guys want to do this. You could do 1/2 base times height, because you have that information. You can do 1/2 perimeter times apothem, completely up to you. But I know that because this radius, this red radius is 6, the height of this triangle right here is also 6, which means if I was to do 1/2 times the base times the height, okay, I'm left with 27 root 3. If I was to do 1/2 times the perimeter, 6, 12, 18 root 3, times the apothem, which is 3, I'm still left with 27 root 3. So it doesn't matter. This was 1/2 times the perimeter times the apothem, and this is 1/2 times the base times the height. Okay, 2 different ways of finding the area of an equilateral triangle. This works, of course, for every triangle. This is only for your regular shapes. Okay, number 16. So, a circle is inscribed in a regular hexagon and circumscribed about another. So essentially what that means is you have this pink hexagon and there's a circle. Okay, I'm going to do this the orange circle. And then on the outside, we have another green hexagon. So this one took me a second to draw. And so what it said was the circle has a radius of 6. So what I did is I started with just my pink, like picture my green one not even there. Okay, if this radius is 6, look at what I drew to my pink hexagon. Okay, so you guys can see, hopefully, I drew over here. My radius is 6. And then if that's 6, I put in my 30, 60, 90. I found all the sides, and I just did 1/2 times the perimeter. Each of the sides are 6, times the apothem, which ends up being 3 root 3 to get the area of that right here. Okay. Then I looked at my green one. So pretend that the pink one's not there. And again, the radius of the triangle, or the radius of the circle is 6. So what I did is, again, I drew my radius in, but this time I'm focusing on where this radius is hitting the green hexagon. And if you look, this radius is the apothem. Okay, so that radius in the green hexagon is the apothem. So I built in my green triangle right here. I put in the 30, 60, 90. So again, the 6 side is equal to the x root 3 side, and then I solved it. Therefore, the bottom is 2 root 3, okay? And the radius of the larger hexagon is 4 root 3, okay? Because the base was 2 root 3, that means all of the sides are 4 root 3, 4 root 3, so on and so forth. And there's 6 of those. So the perimeter of the green one is 24 root 3, and the apothem is 6. Therefore, the area of the larger hexagon is 72 root 3. Looking at the smaller one, again, this has a side of 6. Each of those is 6. So the perimeter here is 36, and my apothem is 3 root 3. Okay, so then they asked me just to find the ratio. So if you see what I did, I just stacked my pink hexagon up with my green hexagon. I divided those each by 9, and I got the ratio is going to be 3 to 4. 3 to 4. I did one for 17. So again, just how do I find the area of the shaded region? I found the area of the square. Okay, so each of those sides ends up being 36 or 6. And then after you find the area of the square, you have to find the area of the triangle. So again, when you draw this apothem going down, you do have a 30, 60, 90 because this is an equilateral triangle. This base turns into 3. Okay, we already know this is 6. Therefore, the apothem is 3 root 3. And then again, it's up to you if you want to do 1/2 base times height. That's what I did right here. The base is obviously 6, and the height is that 3 root 3. You can also do 1/2 times the perimeter times the apothem. Oh, we don't have the apothem in this one. I'm tired. So this one we had to do 1/2 base times height. Okay, and then B and C are essentially the same.